Hello physics students, and welcome to this video, your first video on real physics content. So this first chunk of physics that we're going to be covering this school year and for a portion of the school year is referred to as kinematics. And now what kinematics is just it's how we describe the motion of objects, and we can describe the motion of objects using a lot of different things. We can use math equations to describe motion. We can use graphs to describe motion. We can even use words to describe motion, and we're going to be doing that a lot in this class. Now, before we get into our first aspect of kinematics, there are some quantities within physics that we need to be aware of, because a lot of the quantities, well, all of the quantities rather, that we're going to be dealing with can get boiled down to these two quantities right here. So first, we have scalar quantities. And scalar quantities are quantities that are just fully described by a magnitude or a numerical value. Now on the flip side, a vector quantity is fully described by both a magnitude or a numerical value and a direction. So the difference here being between vector and scalar is that a vector has a direction, a scalar does not. Now, just to give you a quick example of this, I think it's pretty self-explanatory, but let's say that I went out and I walked 22 blocks. I don't know where that would actually get me in lacrosse. 22 blocks, I could probably get down to what, Granddad's Bluff maybe? So I walked 22 blocks. 22 blocks as it stands here is a scalar quantity, because all we have here is a numerical value. Now I could say I walked 22 blocks east, and because I put this east here, a direction, this is now a vector quantity. Okay, so first things first, kinematics is how we describe the motion of objects using a bunch of different things, and we need to be solid with what scalar and vector quantities are. So the first aspect of kinematics that we need to be really solid with is distance versus displacement. And I think a lot of people think that these two terms are the same or that they can be used interchangeably, but they cannot. Distance is a scalar quantity, and it tells us how much ground has actually been covered during an object's motion. Now, another way that I like to think about distance is that it is the total path traveled by an object. So distance would be the total path traveled by an object. Now displacement, unlike distance, is actually a vector quantity. And it's telling us how far out of place an object is from its starting position to its ending position. And I think maybe a better way to even put this is it is just the object's overall change in position. Now, to give you a little visual of what these two look like, let's say that I want to go on a little stroll. I start at this point here. I'm going to call this position initial or X initial. And I'm just going to go for a nice little stroll. So I'm doing some loop-de-loops. Yay, having a good time. Woo! And I end at this position right here. And I'm going to call this position final or X final. Now, if we wanted to figure out the distance that I traveled, we would have to figure out the distance of this whole path here. So that would be the distance of my journey. If we wanted to figure out my displacement, we would just be drawing a straight line between my initial position and my final position. So this blue path is my distance, and my displacement is simply the straight line distance here. Now, in physics, we typically have verbal definitions for things, like we do up here, and we always have a mathematical definition which correlates with that verbal definition. Now, for distance, we don't necessarily have a set mathematical definition. Let's say that we had a path. Let's say that I start at this position and I go up and I go over, and I go down. And I'll just call this D1, D2, D3. For us to figure out what the distance is in this scenario here, what I would be doing is just saying that distance is equal to the sum of D1 plus D2 plus D3. So with distance, all we're doing is we're just adding up all the different moves that we make in a particular scenario. Now for displacement, we have a more formal definition. Displacement, we have a more formal definition. We know that displacement is the overall change in position. So we're going to say that displacement, and we use this symbol for displacement because what this triangle means here, this is delta, and delta means a change. So we have a change in position that is going to be equal to our final position minus our initial position. Okay, so our change in position is equal to our final position minus our initial position. That is our mathematical definition for displacement. So these next two slides that I'm going to go through are just going to give us some practice in actually calculating distance versus displacement. Okay, so what I'm going to do right away is I'm going to label, well, let's start out with this. I'm going to start at this position right here. This is going to be my position initial. And if you take a look at this graphic here, we actually end at that same position. So I'm going to label that XF as well. Now, the next thing I'm going to do is I'm going to label this A. I'm going to label this leg up here B, this leg here C, and that leg there D. First thing that I want to find in this scenario is I want to figure out what my distance is. So I'm going to write D is equal to. Now again, it's just the total path traveled. So all we have to do here is sum up leg A, leg B, leg C, and leg D. So we're going to say that DA plus DB plus DC plus DD is equal to our distance. And now we can just plug in our values. And if we add all those up, we're going to get a distance value of, let's see if I can do simple math here, 12 meters. Next, finding our displacement. Change in x is equal to position final minus position initial. Well, let's just call this 0 right here. So our final position is 0 meters, and our initial position is also 0 meters. Because we started and ended at the same point, our displacement is 0 meters. So this is a really good example to get us into this idea of thinking that distance and displacement are not the same thing, because we got two different values for distance and displacement. All right, so our next scenario that we have here, we have a skier, and he has an interesting path going on here that we want to take a look at. So first things first, we want to understand what's going on here. So at position A here, we'll just say that this is at 0 meters. At position A, our skier is going to position B in 1 minute. So we're going from A to B. Now, from 1 minute to 2 minutes, we're going from B to C. And then from 2 minutes to 3 minutes, we're going from C to D. So the first thing that I want to find in this problem is I want to figure out what our distance is. So we need to sum up all the different moves that this skier took. So the first is going to be the distance between A and B. So I'm going to write distance between A and B plus our distance between B and C. And then finally, our distance between C and D. Okay? Now, we can actually plug in these values to figure out what the distance was. So from A to B, we have 40 meters plus 100 meters plus 40 meters. That total distance that we took from A to B is 180 meters. Now from B to C, we're going back 40 meters and 100 meters. So that is going to be 140 meters. Finally, from C to D, we are going 100 meters. And if we calculate that out, we are going to get a distance value of 420 meters. Now, to find our displacement, remember displacement is equal to position final minus position initial. We need to take a look at where we ended. So we ended at D here, and D is actually 140 meters from where we started. So I'm going to write in 140 meters. And then our initial position here is just 0 meters. We started at 0 meters. So, doing that simple math, we get a displacement equal to 140 meters. Now, there's a couple things that I want to note here. Typically in physics, we always denote the positive direction as the rightward direction, and the negative direction is the leftward direction. When we were figuring out our distance, when we were going from B to C, we were actually moving in the negative direction. Now, the reason that we didn't subtract off that 140 is because distance is a scalar quantity. All we're worried about is just the total path that we traveled. We're not worried what direction we're moving in because it is a scalar quantity. So all we had to do was just add up the distances that we traveled in this scenario. Now, displacement being a vector quantity, we are concerned about direction. So this 140 meters that I have here is actually, well, it's correct, but it would be more correct if I would have written positive 140 meters. Okay? Now I know without that positive sign there, we look at this as positive, but to be sure that we are being conscious of direction, we're going to put a positive 140 meters there. Now let's say that we wanted to find our displacement between position B and position C. So we want to find our displacement between B and C. And we know that our equation is position final minus position initial. Well, our final position here is actually 40 meters.
Hello, Aquinas.
So we're going to write down 40 meters.
Just a reminder
And our
that
initial position here is actually 180 meters. So if we do that math, we get a displacement of negative 140 meters. So in this case, direction becomes very important. And the direction really takes care of itself if we keep in mind this equation. Where do we finish and where do we start? I hope this tutorial was helpful. I got some announcements going on behind me here. But thank you, physics students, and take care.